Bismillahirrahmanirrahim. Today we are here with another lecture of integration, and this question is about group 2, which we discuss in previous lecture. And in this group we put question number 19 to question number 28. Today we are going to discuss question number 19 to 28 and some other questions as well. So let's start our question from question number 19. Here are some other techniques of integration. In our previous lecture, we will discuss some and three most important techniques of integration, which are about x square minus a square minus x square, and a square plus x square. If we have this kind of question, we will substitute x is equal to a secant theta. In this type of question, we will substitute x is equal to a sine theta, and in this type of question, we will use x is equal to a tan theta. Here is a question about first type of substitution. The question is integral I is equal to square root of x square minus a square upon x raised to the power 4 dx. Here we substitute x is equal to a secant theta, the derivative of x is equal to dx, and the derivative of secant theta is secant theta tan theta d theta. Now substitute the value of x and dx in question or in equation number 1. We have I is equal to integral square root of a square secant square theta minus a square upon a raised to the power 4 secant 4 theta, and the value of dx is equal to a secant theta tan theta d theta. After simplification, we will cancel out a secant theta with a secant theta, which is present in denominator. So take a square as common. From square root, we will have secant square theta minus 1 inside the square root, and outside the square root we have tan theta d theta upon a cube secant cube theta. Put the value of secant square theta. You know that secant square theta minus 1 is equal to tan square theta. So put the value of secant square theta minus 1, which is equal to tan square theta, and this square and this square is cancelled out with square root, and we will have a tan theta upon a cube secant cube theta tan theta d theta. A and a cube will cancel out and give the value 1 upon a square. As 1 upon a square is constant, so we will write this constant outside the integral and have tan square theta over secant square theta. Now as tan square theta is divided by secant cube theta, and we have more simplified trigonometric identities used for tan square theta and secant cube theta. As we know that tan square theta is equal to sine square theta upon cos square theta, and secant cube theta is equal to 1 upon cos cube theta. So after substituting these values in above expression, we will have 1 upon a square sine square theta upon cos square theta, and reverse this process. Reverse nahi, inverse. After taking inverse of this process, change division into multiplication, and 1 upon cos cube theta is equal to cos cube theta. After cancellation, we will have sine square theta cos theta d theta. Here is another technique of integration, and here are two different methods of integration. First is direct method, and second is another substitution method. If we take direct method, we will see that the derivative of sine theta is present in the product of sine square theta, that is cos theta. If we have the derivative of any value and its product, we will use product rule, and it will become 1 upon a square sine theta raised to the power 2 plus 1 upon 2 plus 1 plus c, which is equal to 1 over a square sine cube theta upon 3 plus c. And the other alternate method is this. Let's make another substitution, which is sine theta is equal to t, and we have 1 upon a square t square cos theta is equal to dt t square dt, which is again equal to 1 upon a square t3 over 3 plus c. Now back substitute 1 upon 3a square. The value of t is equal to sine theta raised to the power 3 plus c. Here are two different substitutions used in this question. Now put the value of sine theta from this substitution. Here x is equal to a. Secant theta is our first substitution, and from this substitution we will get x upon a is equal to secant theta, or a upon x is equal to cos theta, and the cos theta is equal to perpendicular over hypotenuse, base over hypotenuse, which is equal to this. And after using Pythagorean theorem, we will have x square minus a square along with square root, and the value of sine theta is equal to x square minus a square upon x. Put this value in equation number 2 and find our final result. The next question is question number 24, 26 and 27. Question number 24 and 26 are almost similar. So I have decided to solve question number 26, which is equal to integral 1 plus x square raised to the power minus 3 by 2 dx. In previous question, we have already learned that if we have a square plus x square type of question, we will substitute x is equal to a tan theta. And in this question, we have 1 plus x square. So take x is equal to 1 tan theta. 1 represented at square of 1. So x is equal to 1 tan theta, and the derivative of x is equal to dx, and derivative of tan theta is equal to secant square theta d theta. Now substitute the value of x and dx. In above expression, we will have I is equal to integral 1 plus tan square theta raised to the power minus 3 by 2 secant square theta. Use the identity secant square theta instead of 1 plus tan square theta. We will have secant square theta raised to the power minus 3 by 2 into secant square theta d theta. Cancel out 2 with 2, and we have secant theta raised to the power minus 3. Here is another expression of secant theta, which is equal to secant square theta. Now collecting both expressions, we will have secant theta raised to the power minus 1 d theta. As minus 1 shows the inverse function, so take this term in inverse form, like secant raised to the power minus 1 is equal to 1 upon secant theta d theta, and 1 upon secant theta is equal to cos theta. The integral of cos theta is sine theta plus c, and you can find the value of sine theta from our first substitution by using Pythagorean theorem. So by applying Pythagorean theorem on this triangle, we will get the value of sine theta as x upon 1 plus x square plus c, which completes our result. Similarly, we have question number 27 as x square upon x square plus 1 with a square root. Now simplify this expression. As the square root is present on x square plus 1, so we will not make usual Dewey algorithm. So we just make the expression in denominator on numerator. For this purpose, we will add 1 and subtract 1 on numerator. So we will have x square plus 1 minus 1 upon x square plus 1. Now distribute x square plus 1 on x square plus 1 and uh, minus 1 upon x square plus 1. After splitting this, cancel out x square plus 1 with the square root of x square plus 1. We will get square root of x square plus 1 dx minus integral of 1 upon square root of x square plus 1 dx. Here we have two different methods and two different formulas for this question. And for the solution of this question, first method is we already discussed that the method of substitution. To solve this question, we will make substitution as x is equal to 1 tan theta. The other method is this, that in our first lecture we will learn about almost 34 to 40 formulas. By using some suitable formulas in this question, we will get the result. So if we name this integral as I1 and this integral as I2, and after putting the value of I1 and I2, we have a formula for integral square root of x square plus 1 match to this value. So put this formula. After using this formula, we will get x into x square plus 1 upon 2 plus instead of a square we will use 1 upon 2 sine hyperbolic inverse x upon 1 minus the formula for this expression is sine hyperbolic inverse x upon 1 plus c. Now take sine hyperbolic inverse x as common. We will have 1 by 2 minus 1 into sine hyperbolic inverse x plus c. After simplification, the new expression is minus 1 upon 2 sine hyperbolic inverse x plus c. The most important question about this topic is question number 23. Here in this question we have 1 upon square root of 2x square plus 3x plus 4. As we see that there is no complete square in this question available, and we will make this question easier. For this purpose, we will take 2 as common from above expression, and we have 1 upon square root 2 into x square plus 3 by 2 x plus 2. Now we will make it complete square. For completing square, I will discuss the method of completing square here. Here x is the whole square of x and 2 is the product of a into b, x into 3 by 4. Add and subtract 3 by 4. Square of 3 by 4, we will have x plus 3 by 4, whole square of x plus 3 by 4, and simplify the square of 3 by 4, which is equal to 9 by 16 plus 2. Again simplify 9 by 16 plus 2, and we will get minus 9 plus 32 upon 16, which is equal to x plus 3 over 4 plus 23 upon 16. We need here the both expressions are in square form, so we will put square root of 23 along with its square and square of 4 instead of 16. So we will get x plus 3 by 4, square of x plus 3 by 4, and square root of 23 upon 4. Now replace these terms in this expression. we will get 1 upon square root 2 into x plus square of x plus 3 by 4 plus square root of 23 upon 4. Here x plus 3 by 4 plays the role of x and square root 23 upon 4 plays the role of a, and we have a formula for this expression which is equal to 1 upon x square plus a square dx is equal to sine hyperbolic inverse x upon a. If we replace the values of x and a in this formula, we will get 1 upon square root 2 sine hyperbolic inverse and x plus 3 upon 4 and square root 23 upon 4. After simplification, we will get 4x plus 3 and 4x plus 3 upon square root 23 plus c. Similarly, here is the question number 25. You can solve it. If you don't understand this question, you can ask, you can message. The next question of this lecture, the next question is question number 28. I think I should complete this question, and after this question I will end it my lecture. Question number 28 is 2x plus 4 into square root of 2x square plus 3x plus 1 dx. Now you can see that the derivative of the term in square root is present in its product, like the derivative of 2x square plus 3x plus 4 plus 1. The derivative of 2x square plus 3x plus 1 is equal to 4x plus 3, but in its product we have 2x plus 4. To make its 4x, multiply and divided by 2. Multiply and divided by 2. We will have 1 upon 2, 2x square plus 3x plus 1, and change square root into 1 upon 2 and multiply 2x plus 4 with 2. We will have 4x plus 8. Now split 8 into 3 plus 5 and we will get 4x plus 3 plus 5 dx. Now multiply this expression 2x x square plus 3x plus 1 with 4x plus 3 separately and with 5 separately. So we will have 2x square plus 3x plus 1 raised to the power 1 by 2 into 4x plus 3 plus 2x square plus 3x plus 1 raised to the power 1 by 2 into 5 dx. In this expression, we will see that the derivative of this term is present in its product. So by using the power rule of integration, we will solve this expression as 2x square plus 3x plus 1 raised to the power 1 by 2 plus 1 upon 1 by 2 plus 1 plus 1 by 2 integral 2x square plus 3x plus 1 raised to the power 1 by 2 into 5 dx. By using the techniques used in question number 27, first of all we will complete its square and then solve it, and hope so you can solve it yourself. And after solving this question, you can inform me, and if you will not solve it, then also inform me. I will help it out. Thank you so much. Allah Hafiz.